Welcome, I'm Bill Wake. We're here working on a program to compare tunes for similarity. One of the things we're doing for that is what's called a dendrogram to show clusters, and our dendrogram drawing is a little subpar. We're too scrunched horizontally, so we want to spread that out. All right, let's take a look. Oh, welcome, Mudshark. All right, cool. All right, so we'll open a file and do a cluster. All right. So what you can see is two problems. One is this line starts in the middle of the node, which would be great if the diamond weren't there. It would look like a T-joint of some sort. And we'd like it to start a little bit to the right, so it's outside the node. Actually, I wouldn't mind that little tiny, I don't know, couple points worth of empty space there beside it would be fine. The other problem is you can see that over here where it's crowded because these lines aren't far enough apart, the vertical ones, the node overlaps the previous stuff. So you can see a little bit of a blank corner there because 46 has a little white space around it and it's encroaching on it. So what I think I want to do is I think first we'll move this starting line over a little bit so it's outside the diamond. The line lengths represent distance, so they are mathematically, they have mathematical meaning in the sense that, you know, this line is a quarter inch from that one, that one is further away. And the relationships are, you know, related to the length of the line. If we move them out by kind of a standard amount for each, it's not as relevant. Okay, now the other problem with this is notice the two branches here. If we move this one, the top one over to the right, we ought to move the second one over too. And I'm not sure how I want to handle that. It may be if it's not connecting to something, I don't know. It may be a little white space there would be welcome. It may be we wanted, I don't know. We may decide we want to fill in that little gap, but the two branches can be different lengths. Okay, so that's unfortunate. I don't know if we know. I don't know if we know whether that's an element or a cluster. A cluster is being over here and elements here. Oh, and a third thing, I guess. I would love to have a little bit of a bracket line coming out of these, enough to get it to or just past the leading edge of the diamond. Okay. I don't know what that does to things. Maybe I need to reconceive it. Maybe it's a line, and then the cluster thing is a bracket with a diamond in it, and the bracket is specifically chosen to have that width and the diamond too. Okay. Do we know the depth? I don't think we do. It's certainly something we can add, but we'd have to define it like, you know, 43 here. Its depth on the one side, you know, this is level 2 on the one side and level 1 on the other. So, you know, I could see where the minimum or the maximum might make sense to talk about, or we might need to know the separate depths. Okay. Yeah. That is true. All right, so I think what I'm going to do, my first strategy is going to be, let's move the starting point of the line over so it at least doesn't step on the cluster it's directly involved in. I don't think that changes any relationships, but yeah, maybe there is something to the depth that I don't think that would solve that part, but it would help the overall thing quite a bit. Yeah. Okay. Let's go to code and let's make sure this is current task is accurate here. Okay, well, it's a little generic, but let's start. Whoops. So make top and bottom lines start 1/2 diamond to the right. Okay, this is all dendrogram view. I'm going to close the rest. I think, actually it's our connectors that maybe we have to work on. All right, well, let's look at bracket for a minute here. Okay, so we get a frame width, which is the amount of space we have to work with, and we know if our stage is selected. Okay, so we draw a horizontal line for the top, another for the bottom, another for the vertical line. And we set the width accordingly. Then we draw the diamond, filled or not, and overlay connector ID. That's not going to stay there. It doesn't mean anything. It's helpful to us debugging it, but it's not really meaningful to the user. They have no way to relate that back to what it means. Okay. So, well, we put all the work in the connector, but the connector, see this font size. Okay, that's related to, that's something we control. Okay, so 24 points. I think, well, let's start with connector. And I'm going to just, what do I want to do? Well, okay, we have a problem. Always have a problem. The dimensions, we've written double here, but the scale of this thing, it doesn't have to be this way, but the fact is with our data, we scale things so that they're 0 to 1. And so X is really 0 to 1, which in a way is fine, but in another way it's like, well, that means we can't talk about pixels on this side because we're talking about the scale of our domain side, of our clustering side, which ultimately depends on the equation that determines distance. And in our music application, that gives us 0 to 1. In our test code, we usually just use the absolute difference of numbers, and that gives us sort of an infinite integer range. And the row numbers are just plain ints. Y is based on the row numbers. So again, it's not in screen coordinates, but mostly we'll care about X today. So I thought maybe I could go in here and add those, add that 24 points, but that doesn't mean anything over here. So I'm going to do it over here and probably regret it. The top line, I don't know. Connector.top. Okay, let's go look at horizontal. Okay, we do branch X. Well, that almost sounds like it's not scaled. Okay, let's find more computing connectors. We don't pass anything about the scale to them. Line. Oh, there's the scale. Okay. Well, I can go the other way. I can say I know it's 24 points, although it's probably, in principle, it's probably 12, but then there's probably some amount of space around it. Oh, gosh. So if I took those 24 points divided by the frame width, I think that would give me some distance. All right, I'm going to just, I'm really in a exploration mode. I'm not TDD at this point. I'm just trying some things out. So let's take plus, I'll do 24 divided by frame width. Okay, so I'm trying to start that thing more to the right. X, Y, okay, I'm not going to change Y. Branch length, I think that's going to be plus adjustment. Okay, let's make sure this is all coming out in double land. All right, I'm expecting my horizontal lines to move, my vertical lines in the wrong place. It's definitely crossed my mind that maybe the connectors should be converting things to regular points. All right, so we may decide to go that way. This is the short file and cluster. Okay, well, they're definitely in the wrong place. So 24 is too much to move. Well, yeah, maybe it would be half the. Okay, I've got more space here. Probably too much more space there. That's basically the width, maybe a little less. Okay, I'm gonna try and do the other one too, and just I'll just hard code this for now. 12. Okay, and then the line top X plus length. Yeah, that's the thing. Yeah, it's kind of like, what domain are they in? And this is where I'm feeling clunky about switching domains, and I'm also feeling like you really can't look at the connector and know that that's a 0 to 1, and it doesn't have to be. It can be any length, but in our domain, the connectors, well, they're whatever to whatever. We don't really control them, but we do have to scale them. Okay, so I'm gonna add this one, 12 here. XY delta X, okay, 0. Okay, let's see what we get with this. Yeah, I mean, you're right. It probably couldn't, but here I am trying to manipulate things in terms of pixel widths of, font widths and stuff like that that are more at the pixel scale. It's hard. Okay. Well, our diamond's off too. I guess I got to make the diamond move too before I go any further. All right. Position X framework times level plus 12.0 dash frame width. Yeah, Maybe I should put that layer in that's going to explicitly convert the coordinate systems. Okay, I don't think that looks any better. Did I not move it? Its position. Let's do 24. I don't think I'm affecting it. What's going on here? Position X. Frame width times level. Oh, well, there's your answer. Looks like, oh no, level is not depth. Sorry. Well, let's see if we're having any impact first. No. What is going on? Why would that not matter? Oh, that's already converted to by frame width, so I can. Yeah. Okay, that's getting there. Okay, if I'd moved it half, it might have been better. The line looks thin, but it's just being overwritten by the previous. Okay. All right, let me. Okay, well, I think we don't have everything consistent yet. I'm not sure why. I moved. Yeah, I'm still drawing in the middle of my. Okay, let's. Horizontal line. I'm going to take this off. Oh. Sorry, is what the same with the vertical line? I think I drew this part too long. 12 may not be the right number here. Well, there we have to. This is why I say I'm not consistent. This coordinate 12.0 is in my. Oh, I'm going to say, okay, I'm going to say, I changed my mind. Say, yeah, no, I do have to here, I think. 12.0 is in frame coordinates, pixels, but this argument is in 0 to 1 range. And since they get multiplied by frame width to draw the line by X scale, well, X scale is not exactly the frame width, is it? Yeah, it's okay. I probably should be dividing by both those, but I have to do this to convert it into that 0 to 1 scale, so that when it does this and it multiplies by X scale, it ends up back out to some reasonable level. But this is where I'm saying I think there's no. I don't want to think about it. I think a problem is there's no consistent use, if I had dimensions on my objects, these numbers, you could tell that, like, oh, if I added 12, I'm adding, is that 12 in pixels or 12 in 0 to 1 range? And so I'm kind of mixing and matching those here, which is not so good. But I also think that divide by frame width, I might have to divide by both frame width and diagram percent. Let me try it. I mean, we're just playing, but still. Okay, because I multiply by both those, I should divide by both of them as well. Which I definitely feel like, ugh. Okay. And then that's in frame coordinates, because he's just got to do that too. Frame width comes connector level. I'm surprised that's not X scale, to be honest. Like, this is Y scale, because these are doing X scale multiplications. So it's clear you can, I don't know. I feel like I can mess this stuff up enough that the drawing and the view is really, I don't know. Okay, that looks a little better. I think I could go one back past the skittle connector. Well, that's kind of what I was wondering, is if I gave it the scale. I mean, if I told the connectors, like, you're going to draw yourself in a range of these pixels, and I passed in, like, say I passed in X scale, which is frame width times the percent 3/4. Okay, because it gets 3/4 of the horizontal screen. And then those clusters could be multiplying by their own. They could be doing that multiplication themselves, and then I would get stuff back in pixels, and that would have some appeal. The other, I mean, another way I could look at it is if each of these, I mean, if there was a function on Connector.top to scale it, that multiplied by X scale and Y scale, then I would be working in a pixel domain again. And if I wanted to add some pixels, that's fine, Okay, so I'm going to mess with this a little. All right, can we pass the scale to connector, get the values? Yeah, I mean, I think we could, well, these are branches going in. But a branch, we could certainly tell the branch its scale and when we get its values. Although I think we're just treating it as a bag, bag of data values. It's got a length, it's got an X, it's got a Y. Okay. I don't remember if my branch bracket lines, I think they were still a little excessive. Yeah. Okay. So that was adjusting one more pixel just to see it get more right. Now I think what's happening is the distance, the branch, basically this half the diamond distance, I started my branch half a diamond to the left, but I didn't adjust its length by that distance, or I should adjust the vertical line by that distance, which I thought I did, kind of. Connector top, bottom, X plus line plus 12. And it's X, Y. We don't care about Y, or we're independent of Y. X, we bump to the right 12 pixels. Now let's let's try taking this off. I think that should be the amount it's off. Or let's move this guy 24. Okay, maybe it should be 23 because it's a pixel less, but I don't know if that's the diamond or the size. Okay, well, so much for that. This one looks right. This one looks wrong. Okay. Okay, so that seems like a good adjustment. I notice this corner is still a little, I don't know if I don't have a good way to scale it up, but at least from my view, I can see there's kind of like a missing pixel in the corner, and that's just, I think it's just the sort of half pixel distance or whatever, but we could subtract one from vertical and see if that looks better. Okay, and I've got let's set up a preview. I think we're bouncing around too much. Okay. Yeah. I don't think it's the kerning. I think it's something to do with I'm gonna excuse me. I think it's something to do with, like, when you draw when you have pixels, right? You fill in a pixel, and I don't know, you're it's kind of like it has to draw a length to half a pixel, of its point or something. There's still a teeny tiny little corner in that's inset, but I don't know. I maybe shouldn't worry about it because these numbers are fragile enough as they are. Oh dear. And I also don't know. I mean, sometimes characters don't really quite center in their square. Well, imagine if there's an even number of pixels it takes up, right? Then it can't be centered. So I don't know if that's the case or it's just, just a tiny bit different. All right. Let's see. What can I do here? All right. I know I've done some previews. Okay, we'll do something like this. I don't know if we can get data that's good enough. Ah, boy. Okay, it takes a packet. Well, we set up tunes. Got dendrogram view. Oh, whoops. Thank you. Okay, cluster stage has no member for that. That's fine. We're going to have to mess with stage. I think it's probably tests. Yeah, we did this. That may be enough. Okay. Cloud diagram view. Okay, so we'll create some tunes. Oh, that's not a. Okay, that was added for test support. How bad is he? Yeah, he's more than I want to do. I don't know. I guess I'm going to move that back. This. I'm going to move that up to ABC parser. Okay. And he's not testable. I don't necessarily like that, but okay. Let's. Okay, so that I think will. Well, let's see if that gives us enough to do. Canvas. I've always found this preview stuff to be a bit on the flaky side, but it's got to be better than running this thing over and over and loading up that file. Okay. If I don't know, is that. Let's zoom out. Well, is that enough to help us or not? It's clearly off by one of the lines. It's got junk data in here. I wonder if I could put $0 as the title. Or maybe add to it. Okay, well, that's something. I don't know if I can put this. Well, I got my brackets, anyway, for my 0, I've still got this line going too far in. He's almost going further than ever. Now, I don't know why this is a line off on this one. Is dendrogram view. All right, let's see his collar is cluster view. I don't think cluster view is doing any adjustment. No. Yeah, dendrogram view with a padding and a border on change method, but no, I don't think he's doing anything. Let's add some more. I like it trying to keep up. I mean, wow. Okay. That seems okay. It's just I can't judge it. Can I do scaled to fit? Huh. Scaled, scale effect 0.5. Okay. Let's see if we can squeak out 75. Nope. Okay, I can work with it. Why is this on the wrong line? Here's our draw elements. Yeah, I mean, I think I'm using 0 indexing throughout. All right. Let's close this for a moment. Whoops. Yeah, there's 0. Well, draw elements. I mean, I can. Is it Y scale? I'm going to leave my rare TBD in there because I think I'm doing this for the benefit of our drawing stuff. Okay, let's get back to our canvas. Control, command, no, option, command, return. Okay. Okay, I guess I got to do half that. Okay. This, I'm not clear why we're getting that difference, but I don't think it matters for the purposes of what we're doing. The problem I have here, yeah, I don't understand that at all, but I think I don't want to worry about the why at this point, I guess, and I'm willing to do this to work in the preview. I should let me run it once and just make sure it really does hurt the production view, but We did add some padding. We may have padded something differently. I don't know, but it's not on the outside. It's okay. It looks wrong now. Okay, it is half a line off. Um, okay, but I'm going to, I may be foolish, but I'm going to say let's focus on the X's and not the Y's, and then we can go back on that. But it's it's a little bit mysterious. Well, it isn't actually. I think what's going on is this thing gets told put yourself at zero, and this thing gets told put yourself at zero. But no, is that not right? But we want it to be half the vertical height, so it somehow has to get off by a half. But maybe it's getting off somewhere else. But I don't know. I'm not going to worry about it in the preview. We'll see if I can squeak out 60% here, just to help the visibility a little. Okay, I can get that much. All right. So what I'm seeing is the the line starting here. So, well, I guess like what I wonder is if I said I'm drawing the level and then I'm, it's almost like instead of the diamond, I'm just going to draw this whole bracketed thing and stack that on top of whatever I'm doing. What would be the consequence then? I mean, it would change the relationship somewhat, but I'm mostly worried about this diamond is being drawn through, and normally it was drawing halfway through, and now it's drawing all the way through. So that's because we did shift it over half a diamond's worth, basically. And I still think I can get a -1 in there that will make this look better, but I don't have a systematic reason for it. This -23, which is our font size -1, but I think that gets the line a little bit more over the diamond. Okay. Yeah. So my question is why this horizontal line, the top horizontal line, I would have thought it would be half. Yeah. Yeah. And since they have different amounts, we may have to do something with the depth. Okay. I mean, do I have to adjust my, okay, what if I'm thinking about it differently? If I'm saying the line is the line up to here, and I'm going to compromise on the pure mathematics of it to make things spread out a little more. If you draw your line to here, and then we draw this bracket plus a diamond thing, then like you're saying, every intermediate node means one more bracket thing. So its level is one. Its level is whatever it says it is, plus the number of bracket things. Yeah, we draw the top line to its length it says. Then we got to make bracket adjustments for all the children it has, including itself. And then same thing on the bottom line, adjustments. I guess it's got to be adjusted. Its pure length. Yeah, I think maybe that's the conclusion that every child, we need to know the depth of the children. to calculate this right, I think. Like this one, yeah, this will be a, oh no, he's a bad example. Number 8's a good example. This one's bad because it has two children with equal heights, but this one has three on, depth, two depths over here and one over here. Okay, so this line, it should draw its length, and then I guess it's got to draw 1, 2 extra lines, and then one more with the bracket. Okay, and that says the depth. Okay, now you'd have to ask the left depth and the right depth, and the left, I guess he's going to be some crazy function, right? It's you ask something, the left depth, you'll allow for that many, but you need to know the maximum, and then you got to take the difference, right? Because this one should only draw, it's already drawn its extras, 2 extras worth. This one needs to make it up. So it's kind of like the max of the 2 minus the other one is, yeah, the max of the 2 depths minus the min of the 2 depths will tell you how many branches the shorter one needs to get caught up on depth nodes. All right. So I guess that then, but to your comment, like way early on, if we knew the depth, we can multiply. I mean, we basically need the bracket size, this bracket plus the diamond, which is really the diamond, times that depth number, makes an adjustment on this bracket to accommodate the nodes. And I think maybe that would do the job if you're always starting the next one at the last bracket, or at the equivalent of that. I think you might be okay. All right, so I'm going to revert. I guess I don't have to revert those two, but I'm going to revert this one. Let me just move this back. I put it in domain tests. Okay. And I think I'll keep the title thing and see if that breaks anybody. What was that? Okay, now I can revert this. Okay. And we got changes in this. Well, that preview is kind of handy. We'll just take that over here for a minute. May not be exactly the same, but I do want to use that more if it's working. Okay, and then this can revert. Okay, if I do this, TuneSim project to do, okay. Okay. Right. Okay. So, what I take away, we're going to change our drawing to make this image is going to become a couple of lines. Well, it's going to be messy. Okay. Well, one takeaway is we'll make our connectors know their maximum depth. That should be enough information to get the extra lines drawn. Then drawing this, we're either going to stretch this one out by that depth or make it part of the, draw it specifically down here with two lines, a line that represents how far it has to draw from the top node and how far from the bottom node to catch them up to the equal amount, and then draw the horizontal line. So I kind of had to adjust these, I guess. Okay. And then, man, again, I'm kind of worrying about being in pixel domain versus domain coordinates. All right. And I don't want to restrict it to 0 to 1, but that's just the way it is right now. And we've probably used that fact somewhere. All right. So connector gets depth, and then we're going to have to work on the drawing, I guess, is the bottom line of it. The other one that kind of went on my head on the connectors, we defined elements, but we don't connect them up. So a cluster, sequence number, he's got this information, but he doesn't have anything about the elements, and he doesn't have anything about his children. So you can't get to the children from the connector. We can gather information as we populate it, but I wonder, partly the reason we didn't connect these up is because the drawing code, it's really designed to support the drawing code, but it's kind of in the domain side of things. It's a bit fuzzy, but it's sort of both. So let's see. So the connectors are made so there can be a list of connectors, and you can zip through them with a for each in the drawing code. If they were a tree, I don't know that you can't do it, but it's more complicated. And maybe they could be better off as a tree, and I should learn the techniques of drawing trees with Swift UI that way. Might be worth learning. Okay. But we want this depth plus 1. Yeah, so I think it's going to be the max of the two child depths plus 1 for itself. Yeah. And then 0 for a leaf. All right, so let's get connector and connector test. Okay. I think something like this, we can assert on the depth too. Okay, so should ConnectorInfo contain the depth? I guess. This is a 1-level deep cluster, so his depth ought to be 1. I'm going to add it, and then things are going to break. Okay, nobody knows what depth is. Yeah, exactly. Okay. Although I want each of these to be able to answer this question, so I don't feel so bad. Okay, so connector ID 3 connects C1, C2. So his depth should be 1. ID 4 connects C3 and C4. So C3's depth is 0. C4's depth is 1. So he should be 2. And yeah, I can't just compute this on the fly. I really do have to have it. Okay, nodes 2, 3, and 4 connects to children, so his depth is 1. And 5 connects, I think that's the same, right? C1, C4. And his depth is 2. And then the big one. All right. Cluster 1, cluster 2, C1, C2, C3 are all depth 1. That's 6, 7, 8. Now this one, 9, connects C2 with C3, so his depth is 1 bigger than the biggest, so instead of 1, it's 2. And finally, ID 10 connects 1, which is depth 1, to 4, which is depth 2, so his depth is 3. Okay, ID 4 is depth 1. ID 5 is 2. And then this is 3. Okay, now connector. Build connectors. Okay. Well, let's just start with it wrong. All right. So, it's going to run okay. I just did run instead of test, though. I don't think it's going to affect the running of it because we don't do anything with it. Okay. Oh, I reverted. I'm like, how does that work right now? Okay. And tests, all those tests should fail because they're going to have the wrong depth on them. Okay, and is it only those tests that are failing? Yes. Okay. So connector, let's find those tests. Okay, so I think we can say our depths are wrong. I'm not sure why it's, oh, that's just in order. Okay, depth 3 versus depth 0. Okay. All right, so now the cluster, well, in here we have cluster 1 and cluster 2, so we're saying our depth is max of cluster 1 dot depth, which I think is going to have an issue. Cluster 2 dot depth. I guess I could add the 1 in the front. 1 for us plus the max of the children. And oh, these are elements. Yeah. Cluster has no member depth. Okay, but I think we can do that. Level, I think right next to that. Elements have 0 and let cluster with info. Okay. So now these should be getting, oh, did I make a function out of that? No. Cluster has no member depth. Oh, did I just add it to connector? Sure enough. Okay. Is that gonna work? Okay, this is where it's hurting that we don't have our other connectors. Now, can we get their depths? Yeah, can we get them from the connectors? Connector 1. Connector 2. Well, if I hadn't just deleted it. Okay. Let's see if all these tests are happy. All right. Let's see. So make connector know its depth. Okay. Golly. Back to the view. Okay. So I guess what I'm saying is your length is your recorded depth plus, sorry, is your recorded level, which is your distance, plus some adjustment for the number of nodes you contain. And the adjustment is max of the top and bottom minus the min of the top and bottom. Is that right? It's not right. It's max to the 2 minus the top, max to the 2 minus the bottom depth. Okay. Tell you what, let's take a break and then we'll come back and tackle this drawing stuff again. I feel like it's kind of our third time rumbling through it. I feel like this time will be a little easier than the previous two, but it's been a pain every time. So we'll come back and do that. So see you in 3 or 4 minutes, and then we'll go back to some graphical fun. All right. All right, welcome back. Okay. So let me draw on the to-do a little bit. So what I'm saying is, what we're going to do is we're going to draw we have to draw the level. Okay. Let me use the letter L. So we got all these levels. Okay. Now that's the core length of whatever we want to draw. Okay. And then I'm saying we're going to draw something that's the width of the connector for every connector we don't have, if I can say it that way. Well, let's do this one. This one has L, and then it's got a diamond. And then let's put these at the same level. Okay. Well, the diamond's in the middle. Okay. And they're gonna keep drawing. Okay. And then this one is longer. Okay, so he's at the same depth. He drew himself to that length. All right, now we want to put the connector in. Well, okay, this one is going to draw to the length of the next connector. All right, and then these, so we have to allow for connector width, and then same thing here. Okay, but okay, now I'm thinking it's this one. All right, so when his connector comes in, all right, and we're drawing something else, and then we're drawing some other connector. All right, whatever. All right, so we need to allow for however many of these we have beneath us on the other side. So this one has this base drawing amount, plus these two were drawn, I don't know, I'm going to put stars. Okay, those two were drawn. Oh no, it's this. Sorry, I think get my head straight here. This one has to do it. Okay, so he's going to draw his natural width, which would take you to there. Yeah, so this thing's natural width would go to here because it got a 2-character boost from that. So this one needs to draw 2 characters to make that up and then allow for the diamond. Okay, I think I'm there. So anytime I'm drawing a connector, I've got to draw a little bit on the top, potentially a little bit on the top or the bottom. It's not clear which. I'll have to compute which. But I'm going to draw as many widths of my diamond as I need to make up for the other side not having it. All right. And it does mess up the mathematics a little because I'm not trying to take it away from it or anything. I'm just adding it on. But I think it'll be okay. Right. So this means when we're drawing horizontally, I guess we're a cluster. We said draw your top line. And then I think we need to tell it, draw your top line plus as much as you need to make up for the depth. Okay, so this just, the makeup is 0 here, it draws it. The makeup is 1 diamond's worth here, and it draws it. Okay, so I'm telling you, this is getting to be a lot more computation in my view than I really am comfortable with. The scaling was bad enough. Okay, so I'm saying his job is branch his natural starting point, yes, plus the group has to tell me how many extras do I need. Okay, so let's give horizontal line yeah, so I guess we'll call it adjustment of int. Okay, and we're going to say the adjustment here is connector dot. Oh, do I not have enough information? I know my depth. See, this is where I'd really love, yeah, we don't have the children. I'd love to have them here. I think I may have to have them here, frankly, because I want to say I need to know your child's depth. Okay. Well, I've thought that would be helpful for a while, and I'm going to take this out. Adjustment. All right, we may add it back in later, but let's make the connectors do that. I don't. Actual sub-zero build connectors. And build connectors, I think, gives me an array of connectors, right? Excuse me. How do you want to do this? Oh, man. I think I want to add them up top. It's cluster level, and I don't want to keep growing my connector info. But knowing this, I feel like there should be a better way on the drawing side. Yeah, we're indirect, so those are kind of recursive references. Yeah. Now that is going to break all these things. Anybody who gets access from this thing, it. Okay, so if I say you're going to hold the connectors to the children, all right, if you ask the sequence number, I don't care what your children are. I think I can simply, well, what's going to break? That's connector. Yeah, I think if I fix connector, I'm going to find all these other places too. But the element IDs. Okay, some of this could be simpler based on this. Okay, but we're just gonna say I'm ignoring this stuff. We don't need it for now. If I had those cluster children, it would be nice for some things. Okay. I could do these more dynamically. I don't know if that'd be better or worse. Okay, but I'm going to do this minimal change to say I wish my data structure had this. Nobody's really looking for it. Except here. And I'm going to put an element with a dead sequence number. And what else does it need? Row number. Yeah, we could do a recursive call on a lot of these, almost all of these that we're calculating. We probably can simplify this and just access it dynamically, slow it down a tiny bit, but not bad. All right, so now this, I'm putting in element sequence number -1, row number -1. It is junk. Okay. We're just saying I have to have stuff for these things to make a true object. And so I'm putting something in. I'm not using them anywhere, so nobody's going to look at them. So there's no harm in it. So it's kind of a backdoor way to get a new piece in there. But there's going to be other places that may reference connector pulling out the info or something like the tests. Yeah. If it's only one, that's pretty good. Cluster equal expected. Yeah, that definitely paid off. So I think maybe I'm going to flip it around. I have a connector here. We're only asserting clusters, so let's pull out from actual the info. Let info nothing equal. Oh, do I have to do cluster? That's not the right way to do it. I guess I can switch on actual. Okay, so that's kind of a can't happen. And then taste cluster with let info nothing, nothing, and we can assert this. Assert info should be expected. I think I could safely put that in one line. I hate that about this editor. Okay. Switch is exhaustive. Okay. Yeah, so that's the only place that cares. That's interesting. I mean, sure. Okay. Make connector no. It's children in the data structure not yet filled in. Okay, so we've added something nothing's using, which is good because it doesn't work. All right. Connector. All right, so now we want to test that a cluster knows its child connectors. Okay, so this may be fun. Okay, assert clusters equal. Oh, maybe I did this backwards. I think what I want is clusters equal that I think I want to assert connectors equal. Okay, because actual is a connector, and this is just the connector info for one. Okay, let's do that. We're going to build a parallel function. And I'm going to assert connectors equal actual expected. Both are connectors. It doesn't have to be that. Actually, I don't think I need that. I think my connectors are equatable. Connector info, connector is equatable. Okay, I don't need this helper. All right. But we're going to go one at a time. Here's an element. Build connectors from C1 is empty. Okay, but what I want is build connectors is an array of connector. Okay. I'm saying it should be a connector with oh no, it should be let's do it this way. This sub-0 should be a connector. Well, should be connector dot element, the sequence number, I guess 0. Oh, no, that's a element 1. Connector sequence number, row number. I'm going to say 1, 0. Okay, now, does that work? No. Okay. Build connectors C1. Oh, he returns an empty array, right? Okay, let me undo this one. Okay, if build connectors comes back with nothing for a child element, I guess that's true. Yeah, it's an element. Okay, now this one. All right, here's connector info. We're saying we're going to build an actual connector. Actual sub-zero is a connector because that's what this was taking. Oh, let me make sure this still works. Okay. Now, this we want to be a connector. That with connector cannot be constructed. Oh, dot cluster. Probably don't need that. A cluster with. Now this is where I'm not sure we're being consistent, but this should be an element with ID 1, row number 0, and an element with ID 2, row number 1. That's the cluster, and that's the assert equal. Cannot confer. Cannot convert. Oh, just. Okay. Now, my fear is that we don't really keep track of the elements when we do stuff. So I don't know if we're going to get this for free or not. All right, this is going to break because we don't put these in our connectors yet. All right. It has -1 instead of 1 0 2 1. Okay, now that is in connector. Okay, build connectors. Yeah. Well, hopefully we just have to say connector 1 and connector 2. Okay, so if you are building it from connectors, then put those in there. All right, let's make sure this one works. All right, now this one. Okay, so assert equal. All right, this is 3, so it should build up from 0 and 1. Zero, row index 0. 1, row index 1. I think, I don't know how you know that order. Okay, but this should pass. Okay, now we want this cluster. Oh my, that's going to be ugly. Let's pull out this. Is that the right? Yeah. Okay. Because we have to reference this one as well. Okay. So 0, 1 come first, then 2 gets added in. All right. So I got connector 3 here. Now I'm going to do the same kind of assert. Okay. I want to do assert equals again. All right, but this time I need connector.cluster. And then I got to put a closing paren here. And his info is connector 3 and just an element. Line 75. Okay, so that should be passing still. Okay. These are painful to think through. But I think, like you mentioned, we can do recursive calls on lots of these things and simplify some of this. Okay. All right. The flipped clusters. We're building 2, 3, and making 4 first because it's 0.5. Okay. And so I'm going to extract this. His ID is 4. Okay. I'm going to switch him over to a cluster or connector. Okay. And he's element 2, element ID 2, row 0, and 3, row 1. Okay, so that's this one. All right, now this one. All right, now he is connecting C1, which is element, and connector 4. All right, C1's ID is a 1, and his row index should be 2. And connector 4. I think I got an extra one in there. This was flipped. No, he seems okay. All right, let's try him. They can be either way. This one connects 2 to 3. This one connects 1 to 4. Oh, but we did have these rules, didn't we? You're right. Now, why would this one be backwards? Yeah, we generally push clusters before elements. You're right. So connector goes here. Why is that? No, that one failed. Okay. Right. We always push connectors before elements. Now this one, set for 342. It's a set. It shouldn't matter. Element 2031. Is that not what I said? Zero, 1, length 0.5, bottom 0, 2, length 0.5, depth 1, connector element 2, 1, connector element 3, 2. Am I off by 1? Oh, I think these maybe start at 0. The more realistic we get a situation, the more we have to pay attention to that. They flipped to, I don't think they were flipped, were they? 2031. I think 20, this was 2132. Hmm. Two zero three one versus 2132. Why is this not row 1? I think that maybe I hate to do this. Yeah, I really hate to do this. But I think I'm going to have to. This is 1, 2, 3. And now I think this should be 2031. Sorry. 2 element C2 is 1. 2, 1. Now this one, ID is 3. Yeah, I think I'm not completely sure, but I think because the way we number things and all that, that I think it can matter that they're starting at 0, and I think in this case maybe that's it. But I'm not I'm not completely confident in that. But I recall having to update tests with this before. Yeah. Okay, 1, 2, 3 for the set. 1, 2, 3. 1, 0, 2, 1 versus 1, 1, 2, 2. So it's still putting that other element on top. How is that possible? Okay, so if this is 1, 1, 2, 2, okay, is it putting this one in 0? That doesn't seem possible. So element 0. Oh, so hard to read. Element 0, 0. Now this is getting into our clustering algorithm, is why I dislike this. Build connectors has no choice but to look at the clustering, I think. Let's see what it's doing. We're giving it clusters in a starting row, right? Build wait a minute. Build connectors, cluster, and it assumes the starting row 0. Okay. Now this really strikes me odd. Because our first okay, so we got cluster. I mean, our first one that comes in should be that one that's the most connected, right? Because that's child one of the cluster. Okay, let's see, cluster element. Sequence number and the value. Okay. Okay, I don't think we care about the values too much. I mean, when you build the cluster from C5, your first argument is C1. It's cluster 1. Okay, I guess I should look at the test one more time. All right, we got 0, 1, 2. 3 was built up from C2, C3. 4 from C1, C4. Okay, okay. This is the root. Sorry, C5 is the root. He says his first child is C1. That one really is it really is putting that element there. So he really is row 0. Because the clustering algorithm decides which child comes first. This does not. Okay, I think that's where I was confused there. We connectors don't make those decisions. That's on the cluster which one comes first. So he put C1 first, so that one gets assigned first. I don't think our actual cluster building code would do that. I think that's the confusion I have. It would always say, oh, the element goes last. Okay, but this is not enforcing that. It has to go based on whatever cluster it's given and told about. Okay, so that I can see this being 1, 1, 2, 2, because C1 got 0, 0, C2 and C3 come next in that order, and I think they get those. Okay. All right, now what? Okay, element 0, 0, and element, no, where's element 0, 0. Wait a minute. Oh, I'm so twisted around. Oh, it was the same thing there. We told it that was first, and I think that's just going to be first, even though a different clustering algorithm. We're not applying our own clustering algorithm. We're doing something different. Okay. Let's try it again. Okay. Wow. I'm about burning my eyes out on this thing. All right, but now I know it's going to be in the order. I don't think this 0, 1 thing was maybe the problem. Okay, so clusters. Let's start with this cluster. C1 is the first cluster, and C1 has E1, E2. So I think 0 and 1 are going to be the first indexes. So this becomes XETAQ, and this becomes connector.cluster. We're going to need this thing later. Okay. Node, and this is ID6 is E1, E2. Okay. Now we're going to want that later, but that should still pass its test. Okay, there's cluster. And let's call this cluster 6. elements off by 1. So we can ignore the second value of an element because that's just the numeric value that it's using to display. Okay, so I think because C10 says C1 is first and C1 says E1 is first, so this one gets the first index, 0, and this one gets 1. Okay. No. You're kind of saving me here. Oh, my goodness. I don't like it being so hard to think about this, but I don't think I can do it otherwise because I feel like we needed trees of this depth to demonstrate some of the stuff that we saw. So crazy as it is, I think we're doing the right thing. All right, so now we check cluster 6 is good. Okay, now cluster 7. I almost should start with 10, but okay. Now cluster 4 is next, and 4 is C2, which is cluster 7. Okay, so 7 is next, then 8, C3 is 8. Okay, so basically these elements are all coming out in order. All right, so that'll help a little bit. Okay, so this is connector.cluster. And his first element is number 2. Going in row 2. And his next element is 3, going in row 3. Okay, and he's, I'm going to say connector 7. Okay, and then I think we're going to pull the assertions down and this up. And I think I'm going to call this, oops, I don't want that there. I want it here. I'm going to call it expected 7. Because he's ID 7. And this can be expected 6. Okay, now cluster.connector. I'm doing them backwards. Connector.cluster. Okay, so ID 8 C2 and C3. So C3 is cluster ID 8. So we'll call it expected 8 is element 5 and 6. So 4 and 5. Well, I can see we're going to get to simplify our assertions a bit anyway. Okay, now this is cluster 9. Okay, 9 connects C2, which is expected 7, with C3, which is expected 8. Okay, and then one more. Connector cluster. All right, so number 10 is C1, which is 6, and C4, which is 9. Okay. Hope this passes. Whew, good. Okay, and then now this assertion, I can simplify it, right? So AQ, I think actual should be 6, 7, 8. Okay, that should replace these. We'll make sure this line passes and then we'll delete those. Good. All right. Oh. Okay. Oh, all of these should be passing. Let's take a pause and make sure that's still true. All right. And then I don't think anybody else is calling. Oh, no, we do have one more. Is third equal? Clusters equal. Okay. All right. Let's do this one. Connector dot cluster. Okay. So this is ID 4 connects E001. 0, and element 1 is 1. Guess I'm looking at extracted it right. Thank you. I guess I'll leave that sloppy because we're going to come clean it up just like we did the last one. Connector cluster. All right, this is ID 5, which expects C01, which is expected 4 with element 2. And ID 6, which connects 5 to 3. Okay, and then let's do like we did before. Actual should be expected 4, expected 5, and expected 6. so my inclination is to stay over here a little bit, and I think I want to pull stuff out of info if I can. All right, sequence number, I don't think I can. Well, let's do depth first. I know that one's pretty easy. Okay, so the depth, if it's an element, it's 0. If we had connector 1, well, let's call it child 1 and child 2. Okay, the depth is 1 plus child 1 dot depth plus child 2 dot depth, right? These are connectors. Okay. Now that should not break anybody. What do I know? Okay. Balance connectors. Depth. I'm feeling a little overwhelmed here. Okay, what's up? Okay. Oh, you are correct. Yeah, we even discussed it earlier. Okay. Okay, so let's compute connector depth recursively. Okay, now who references this? We don't need it anymore. Yeah, we calculated it there. Okay, but I don't think we need this field anymore because you can always just ask the connector for its depth and it doesn't need to go to the info for it. So let's take this out. All right, and then take it out up here. Up here. Yeah. Do I feel like we're putting stuff in and taking it out all day? I certainly do. Okay, but more than this is going to go away, so I guess that's going to pay for it. Okay, I think we can do this again. Your sequence number, that's something you know. We might want to pull it up to the top level like it is here, but I think for now we'll let that go. All right, now element IDs. So let's see who uses this. Now somebody sets that. Right, should be in here somewhere. Build connectors. Element IDs equals cluster all sequence numbers. Well, that's a true statement. It's also true that it's the same. Those sequence numbers are coming from the ones that the connectors hold as children. That's... I'll let that stand, I guess. Level, top, and bottom. Level is info.level. Okay, so when you build a connector, level is coming from the cluster. Okay. Top cluster one level. Okay. I want to try and drive this one. So cluster one dot level should be the same as cluster two. Sorry, connector one dot level should be the same as cluster one dot level. Is that going to be true? So connector one dot level, well, it comes in and gets set the same way here. It pulls it from its cluster. Okay, so this is a little riskier change. Connector one dot level. I believe it, but we got to see if it works. Two dot level. Okay. So you know level and center and your own level. Okay. So I feel like this will be a good twist. All right, I'm going to run because let's just make sure nothing's extra screwy. We're a little bit off kilter. Oh, got the big one. Or did we revert all that? Yeah, we did. Okay. But notice this all looks like it has been. So I believe that's true. So let top and bottom use a connector level instead of cluster level, since they're computed from their corresponding clusters. Okay, this is one of those big move twists, I think. All right, so now this branch, to me, looks like we can do it dynamically if we're just asked for the top. We know our two children, so we can compute these things and do that. So I think top, did we compute that here? Thought we did. There it is. Yeah. Okay, so instead of doing that this way, let's do it with this. Okay, so cluster, let's do child 1, child 2. Whoops, 1. Child 2. Oh. Okay, so I would like to return this branch. Well, connector 1 is child 1 and child 1 and info.level and child 1.level. Okay, so instead of holding the branch in the parent, we're computing it based on the level plus the child 1. Okay, because that child 1 contributes the top. All right, and now child 2, oh, sorry, where's my branch calculation? Here we go. This should be the bottom branch. Okay, child 2.level, child 2.center, length is info.level, and child 2.level. Okay, again, I'm going to run it just to make sure nothing looks funny. But I think the risky part was the one we did already. Yep, that looks how it's been looking. Okay. Cool. All right, now we don't need top and bottom in our info anymore. Okay, so we'll just take out one of them. There's going to be a bunch of tests that explain the top to us. Oh, center info. Well, that can go away. That one is a little trickier. Okay, so the info top Y. Child 1, child 2. So it's not info dot top dot Y is really, oh no, I'm going to argue myself into trouble here. Is it top plus bottom? Yes, you're right. Okay, so that's top plus bottom. We don't need any of this then. Okay, you're right, because, isn't it? Because top is, this is the old top field. SIMD. Oh, dot Y. Let me diff this one, connector. Okay, the old one was info top Y, info bottom Y. Now it's just top Y, bottom Y. Okay, I think that's correct. Okay. And then top should go away. I'm being a little careful, one at a time. And then that one goes. Okay. Did I miss one? I felt like I did as it went by. Oh well. Yeah, that's it exactly. Remove ConnectorInfo.top. Now unused. And then we're going to repeat it for the bottom. I've already done it. Oops. Connector info, get rid of bottom. All right, should get some complaints. Now all those test sites. Oh, yeah. We could have left these fields in info. I don't think it would have broken anything in what we were doing, but I think the simpler it is, the better. And we had the insights today. We were in here doing it, so it was probably worth it. And I feel like the drawing stuff has been complicated enough. Less information kicking around will help. Now, I do think we could get rid of element IDs, but on the other hand, well, maybe that's worth doing. it's going to be the children of the connector just as well. And then we would just have the ID and the level, which are both absolutely required. And I think we could move them up. Okay, so we'll do that tomorrow. All right, so, oh boy, I don't know how to say what we've been doing here. We spiked improvements to drawing. We added Connector.depth. And we removed unneeded fields from ConnectorInfo. And now I say we want to remove element IDs from ConnectorInfo. And I think pull ConnectorInfo's last two fields up to connector.cluster. Okay, so we did these three today. We'll do a little more cleanup tomorrow and then move back to the drawing stuff. All right, and this is May 2nd. All right, I'm gonna test top and bottom separately. Yeah, that's a good point. I think most of these, yeah, let's add that to the list. Depth and, did we remove something else? Yeah, the ones we deleted from the info, we really should test separately because their test up till now was filling in the contents of that connector info, and now we don't fill in that content, so there really is nothing testing them. You're absolutely right. All right, well, we will pick up there tomorrow. I don't think this will be too tricky to do. It should be done pretty quickly, and we will go back to drawing again. I think we're getting there, though. I'm hoping we can finish this week. If not, it'll be next week, but we're getting there. All right, well, thanks for joining again. Next time is tomorrow, Wednesday, 2 to 4:30 p.m. Eastern and 6 to 8:30 p.m. UTC, as usual. And thanks for joining today, and especially Mudshark, all your comments. Catch you again in the future. Take care. Bye-bye.